लगाता नहीं, तुम लगा लो।
तुम ही लगाओ,
क्या तो, अरे YouTube में आवाज़ है ना।
तुम्हारी आवाज़ है ना काफ़ी।
तुम्हारा भी वैसे ही आता है भरोसा। छठल छठल जितना बदमाश है ना, सब खाली वही पहुँच रहे।
बोलना मत भूलने सा।
सर डॉक्टर इंजीनियर शांतनु राय। हाँ, AGM है, BSN AGM हाँ, उसको पे हम दे देंगे। ठीक है,
इंजीनियर शांतनु राय, इंजीनियर शांतनु राय लिख दो।
यहाँ पे लिख दे रहे हैं, ठीक है। यही है ना शांतनु राय। तो मैम को ओके देने के बाद सर ओके दे देंगे, आप ओके दीजिए ना। ठीक है,
ठीक है, जो भी स्पीच कर लो।
यस सर,
मैडम का हमारी स्पीच के बाद।
यस सर, ठीक।
वहाँ तेरा लैपटॉप में
इसको तुम बोल देना इसके बाद, ठीक है।
ठीक है। स्टार्ट स्ट्रीमिंग, तो स्टार्ट कर दो। स्टार्ट कर दो। पहले जैसे जाने दो, सब साथ में जाएगा।
अभी तो इंट्रोड्यूस करना पड़ेगा,
बैठने के बाद करना।
सर माइक कौन सा था? ये वाला कि ये वाला? हाँ? स्टार्ट करो। Good morning everyone. Welcome to the fourth day of the session of this workshop. I would like to introduce our Head of Civil Engineering Department, Dr. Jeetu Gujur sir, followed by Engineers Santanu Rai sir, AGM of BSNL. After that, our today's guest, Miss Dr. Neeli Ghosh Lala ma'am on the stage, and after that, Dr. Komal Kumari ma'am, Assistant Professor of BIT Sindri.
Good morning everyone. Welcome to the fourth day of our workshop on remote sensing and GIS in research. I hope you all had an delightful and enriching experience over the past 3 days. I, Jagati Singh.
And I, myself, Aryan Singh. And we are from the Department of Civil Engineering, BIT Sindri. Today's session promises to be just engaging and full of learning. We have an exciting lineup of the expert speaker who will delve deeper into the fascinating applications of GIS and remote sensing. Now, I would like to invite Dr. Komal Kumari ma'am to facilitate Dr. Neeli Ghosh Lala ma'am with a bouquet. Ma'am, please. Give a big round of applause.
Now, I would like to invite Dr. Jeetu Gujur sir, Head Civil Engineering Department, BIT Sindri, to felicitate Engineer Shantanu Rai sir, AGM BSNL, with a bouquet. Thank you, sir. Let's begin with our first session of the day. We are honored to have Dr. Neeli Ghosh Lala ma'am, Associate Professor at BIT Meshra, Ranchi, Jharkhand. to guide us through her knowledge. Dr. Millie Ghosh Neelana Ma'am, Associate Professor.
रुक जाओ सर, टेक्निकल चेक कर रहे हैं। Sorry everyone for the inconvenience caused. Now I would like to invite our Head of Civil Engineering Department, Dr. Jeetu Gujur sir, to inaugurate this workshop of the 4th day.
Very good morning to all of you. On behalf of Civil Engineering Department and Organizing Committee, I welcome you all on this 4th day of workshop on application of remote sensing and GIS in research. I also like to welcome our today's speaker, Dr. Millie Ghosh, Associate Professor from VIT Mesra. I also welcome our one of the guest of honor today, Engineer Shantanu Rai, AGM BSNL Ranchi. I also welcome all the participants who are constantly with patience they are attending this workshop. Dr. Millie Ghosh, today's speaker, is PhD from IIT Roorkee, and he is very known academician and researcher. I hope she will be talking on geographic information system and its application in geospatial research. So, I am very much sure that this will benefit our participants, and they will enhance their knowledge in using these tools in their research work. Dr. Millie Ghosh is a very known personality in the academic and research. She is awarded by Women's Astha Award by is it ma'am? Women's Aparajita Award by Prabhat Khabar Society. So, it is an honor to us to have the ma'am today. And Millie Ghosh, I am also thankful to him because with our small span of time we have contacted him and he's accepted our invitation. This shows that his dedication and responsibility towards the exchanging the ideas and research to the society. So, we are very much thankful to madam to be here. And finally, I thankful to the participants for their active participants. With these words, thank you very much. One very
We are honored to have Dr. Millie Ghosh Neelala Ma'am, Associate Professor at VIT Mishra, Ranchi, Jharkhand, to guide us through her knowledge. Dr. Millie Ghosh Neelala Ma'am, Associate Professor in the Department of Remote Sensing at VIT Mishra, has a distinguished academic record with a PhD in geomatics from IIT Roorkee and an MTech in remote sensing from VIT Mishra. Recognized with the Jharkhand Aparajita Samman for her contributions to planetary remote sensing. She is a life member of several prestigious societies, including the Indian Society of Remote Sensing. Ma'am has guided numerous PhD scholars and published extensively in reputed journals and conferences on GIS applications, planetary sciences, and environmental research. As co-principal investigator, she has contributed to high-impact projects funded by ISRO and DST. Her active participation in Chandrayaan mission workshops and international forums highlighted her significant role in advancing geospatial research.
Ma'am is renowned for her expertise in GIS and geospatial research. Hence, without further ado, let's welcome her with a big round of applause. Ma'am, please.
Just a few words from sir. Okay.
Now I would, sorry for the inconvenience. I would like to first call Dr. Shantanu Raisar, Engineer Shantanu Raisar, AGM of BSNL Ranchi, to deliver a few words.
Sir.
Sir, please.
Respected ma'am and our special guest and all students, good morning to you all. And today we have gathered to hear a lecture on GIS and its application in the workshop. Although if I have some knowledge about it, I have done MTech on it, although I am on the different stream now presently, but its application is everywhere. Nowadays, in the future, coming days, everywhere if you see in the space technology, India is in a very pinnacle stage, and in the whole world you can see that India is at a it is achieving one of the greatest milestones in all the fields of remote sensing, in this Mars mission and Moon mission, and many other countries are collaborating with us. And this particular remote sensing, we are pioneer in it nowadays. And this technology is being used in every field, say civil engineering, town planning, urban planning, telecommunication. Nowadays, all the countries were using, and we are also nowadays for every activities we are using this technology, because the best planning way is first use the satellite maps, the all the drone maps. After mapping only we can plan better all the whatever future growth will be there, what will be the next 50 years planning we have to do. Based on this only we can create a very good infra. So without taking much time, I would rather like all of you to listen to her, and very thank you for welcoming us. Thank you. Thank you.
Thank you, sir, for such a grateful words. Now, I would like to call, without any further ado, Dr. Millie Ghosh Neelala ma'am for a technical session. Ma'am, please. Give a big round of applause for ma'am.
Thank you for a nice introduction, and good morning to all of you. First, I would like to thank Dr. Kuzu to invite me for this workshop, and I got a chance to deliver lecture and interact with you all. So without any delay, I would like to start. See, GIS geographic information system nowadays all of you are using actually in your day-to-day life. All of you are using Zomato services, you are using Ola and Uber services. They are based on GIS created maps only. In your all of you are now nowadays using your Android mobile and GPS is there. So all of you are aware of or user of these geospatial techniques. Basically GIS is part of your geospatial techniques, or other keywords for this is geoinformatics. And under this broad umbrella there are 4 main branches which are coming. First is your remote sensing, second is your GIS or geographic information system, third is your global navigation system or satellite navigation system. GPS is also the other name because first USA has developed this system. Then your photogrammetry. So I think my previous speakers already have covered this basics of remote sensing, but a few things I am giving you again. As it is shown in the figure, remote sensing is acquisition of information from the object without being in physical contact. And here there are 2 mode of remote sensing, active and passive, and mostly it is passive. Only in case of radar and LIDAR it is in active mode. So in case of passive mode which is okay, it is I am compatible with keyboard also, no problem. In case of passive remote sensing, the source of energy is sun. Basically in remote sensing, what is the main thing which are required? It is electromagnetic wave or EMR. And we know that spectrum starts with cosmic rays, then gamma rays, then X-rays, ultraviolet, visible, then microwave, in between thermal is there, and then finally radio wave. So remote sensing is done in 3 different wavelength ranges. First is your visible, which ranges between 0.4 to 0.7 micrometer, means our eyes are also capable of seeing the things in that wavelength range. Then your thermal, and finally microwave remote sensing. In case of optical remote sensing or which is done in visible range, the purpose is to gather the information of chemical composition of the subject or the object under study. Means different in different wavelength ranges the purpose is different. If you have to know the information of earth object, means thermal properties of earth object, then we have to choose the wavelength range in thermal case like 3 to 5 and 8 to 14 micrometer range. If you have to gather the information of topography, means we have to go for microwave remote sensing. And in case of microwave remote sensing, back scattered energy is sensed by the sensor. In case of thermal, emitted energy is sensed by the sensor. In case of optical, it is reflected energy which is sensed by the sensor. In case of this diagram shows passive remote sensing, that too in optical range, because here it is sun is source of energy. The actual physical quantity which is sensed by the sensor is radiance. Radiance is what unit of radiance is watt per meter square per steradian. It is radiant flux leaving the surface per unit area per unit solid angle. This radiance is converted into, or it is quantized into digital number. whenever, I think all of you have seen sometimes satellite image. You have explored Google Earth. You have seen your hometown, where is your institute, where is your home, like that. So those images are your satellite images, and when you open those images in any image processing software, if you click anywhere in the image, it will give you digital number. Pixel values is digital number, that is your quantized value of radiance. Actual physical quantity is radiance, which is changed by the sensor, and digital number which you are getting in the form of satellite image, it is digital number, quantized value of radiance, and that need to be converted into radiance, then reflectance, if you have to go for further analysis. Because see, in case of remote sensing, it is that we have directly, we cannot rely totally on remote sensing. You have to go for field check at least for 10% of the area, and during this field check you have to carry that handheld spectroradiometer which gives you reflectance, and here in satellite image we are getting radiance. But nowadays if you, some of you have downloaded your LIS3 image from Landsat, from IRS series, from Bhuvan site, or Landsat 8 or Landsat 9 images from USGS. So it is available in reflectance form also, means L2 product. Okay. So that product can directly be compared with handheld spectroradiometer output, which is in reflectance form. So next in the geospatial techniques is GIS, and today we will discuss in detail about GIS. Basically any geospatial project if you have to go for, so at least three things you have to use: remote sensing, GIS and GPS. Photogrammetry can sustain alone, but sometimes it is also needed. And see, in most of the projects we are using the product which is developed by photogrammetry, like a digital elevation model. Digital elevation model is one such product which is being used in every geospatial problem solving project. Okay. Basically why we are using this geospatial techniques? Because we have to solve complex real world problem which are having spatial nature. Means there are some problem which are having a non-spatial nature, there are some problem which are having a spatial nature. Now the question comes, why to go for solving a problem? First of all, there must be some problem, there exists some problem. So when a problem can exist, when we can say yes there is a problem? If there is a gap between your existing state and expected state, जो आपके पास है, जो आप पाना चाहते हैं, उसके बीच में अगर गैप है तभी आप चाहते हैं कि प्रॉब्लम है and you want to solve. So if the nature of such problem is spatial one means it is occupying some space in three-dimensional environment and locational information is tagged with that, so that feature or phenomena is termed as spatial. Like reservoir is there. Reservoir is occupying some space in three-dimensional environment. But the property of reservoir means what is its perimeter, what is the water content, total water content, what are the sediments nearby that reservoir. Those attributes, those characteristics of that spatial data or that reservoir is termed as non-spatial data or attribute data. So why we are using geospatial techniques? To solve complex real world problem, and when the nature of problem is spatial one, GIS comes into the picture. And finally, see, suppose you are you have to solve some problem. So So you have to collect data from remote sensing technique, you have to collect data from GPS, sometimes photogrammetric technique, but final compilation is always done in GIS environment. So GIS in anyhow you have to use, okay, for any problem solving case. Next is your photogrammetry. See, in case of GIS, first GIS is everything is which are there in the real world as represented as a different layer here in case of GIS. We will discuss in detail what are those things and how we are representing this. So third domain is photogrammetry. Photogrammetry is taking measurement from the map. And see, photogrammetry is basically the art of taking measurement from the photograph, and here stereo vision is involved. Like in our human body there is one remote sensing, that is remote sensor is there. There are 5 sense organs. Yes or no? So there are some sense organs for which EMR is used. Electromagnetic wave is prime requirement. Ear is also sense organ, but for ear we do not require EMR. Do we require? So what is the requirement for ear? Sound wave, okay. But in case of eyes, we require electromagnetic wave. So remote sensing technique is working or based on same principle in which our eye is working. Means in our human body, eye is one such remote sensor. Now we are having 2 eyes. With the help of these 2 eyes, we have got the vision of 3D vision. If we had only one eye, then we are not able to view in complete sense, in any object in complete sense, means 3D vision may not be possible, okay. So this photogrammetry is based on stereo vision technique. And in case of this digital photogrammetry, different stereo pairs of satellite images are being used to generate digital elevation model, and based on that measurement of height, measurement of buildings, those things can be done. And there are different softwares are available to perform this task. And GPS, the 4th domain under geospatial techniques. See, you must be knowing that nowadays, means since 2022, geospatial techniques has been introduced in GATE. Earlier this in GATE exam, this subject was not there. So being students of civil engineering, you are appearing for GATE, you can also go for GATE in geospatial techniques, and there are different dates also. Same day exam is not conducted, different dates are there, 2 dates are there. Now this GPS already you are using, it is there in your mobile, and you are sharing location. That sharing location is possible because GIS signals your mobile set is receiving those GPS signal. So minimum 3 satellites are required to get the locational information, and 4th is for time. So 4 satellites are being used at a time to get the exact location of any point. Now we are going in detail what is GIS. Basically in GIS different real world features are represented in different layers. And why those layers and what are those layers? What is spatial, what is non-spatial, we have already discussed. So basically in phenomena we are seeing in the world, those things we have to create in digital environment, then only we can solve the problem. Nothing is there. Undulations are there, but it is continuous. Like